of services. It allows us to build workflows to do orchestration and automation. When we talk about cloud computing, it's a lot about automation. So there's nothing like a pure Microsoft data center, as I mentioned. Most probably, the bigger your environment, the more vendor you have. You might have different hypervisors. You might have different backup system. You might have antivirus. The key thing is in a cloud environment, you want to connect all these things. You want to integrate. You want to have a solution which you can automate. And the strength of Microsoft System Center is it is integrated by default, all the System Center products, Operations Manager, Config Manager, Orchestrator, Service Manager, Data Protection Manager. But you can replace, if you say your help desk tool or your CMDB tool, you invested already money in Remedy or whatever it is called, you can use them. It will be a little bit more difficult to integrate. You need to do more work. And you need to have tools like Orchestrator to do it. But it's possible. So we will see now the areas. Orchestrator is a tool which opens new ways. So you will have on the Orchestrator people working from the development and people working from the infrastructure side. We will see a new generation of IT people, which we call infra dev. So you need to have understanding of infrastructure and you need to have the skills for scripting, for doing some stuff. So our orchestrator is at the end there, and we will see it later, the architect. We don't see anything, sorry, 1 second. So, sorry, so now it's there. So we have at the end the IT professionals which are enabling certain workflows. The thing is about integration automation, as I said. And you will have distributed servers, that's our runbook servers, which are executing stuff. We have a database where it is hosted, and then we have web services, how we trigger the whole thing. What we want to trigger are different areas. Configuration management, monitoring, protection, service management, provisioning. I go that far, we can automate, we can control things, we can integrate with almost everything which has a power switch. So you have a broad set of ready-made information, but you can also extend it individually, which I will show later. So on the orchestrator, on the architecture side, you have a database. That's a SQL database that holds the current jobs, the current runbooks, and is doing the logging. You need a management server. That's the tool which is executing when we do new runbooks. So you use a runbook, you create one. This is talking between the runbook designer and the database where it is stored. Runbook designer is a front end. That's the tool where you build your workflows. Runbook servers, that's where the whole thing is running, where it's executed. One runbook server can hold roughly 50 concurrent sessions, so you can have multiple, and concurrent means really at the same time. So it is pretty scalable. You have a web service which you can use for a web interface and also to execute via the web services certain activities, which we will see in more detail later. That's a complex architecture split up. In a small environment, it can be a single box. Normally what we do, we separate the SQL component from the rest. When we look now on the integration part in the whole system center, in a full private cloud, you have two key components. One is the service manager, which is not only a help desk tool. That's your CMDB, your central configuration management database. And this has all your information from the system. And Orchestrator, which is doing the workflows, which allows between them. So when we look now, of course, there's communication between Orchestrator and Service Manager. Service Manager is triggering through Orchestrator certain tasks. Service Manager gets a lot of data from our environment, from all the System Center products. They are writing into the Service Manager. That's our CMDB. We get from Active Directory the users, computer accounts, computer groups. We get from Configuration Manager our software packages. When we do a full deployment, we want to have change management. I deploy a new software, I want to have it registered in my central database. Ops Manager gives data to the Service Manager, Virtual Machine Manager, our distributed applications, our servers templates. We have integration in Exchange for notification channels, line of business application, third-party management tools. This is at the end what we need for the Orchestrator. So whatever tools you have, you can't connect directly to Server Manager, would go Server Manager, Orchestrator, and then to the third-party management tool. That could be a remedy. That could be a HP Service Manager or whatever tools you have in order to automate, to manage certain things. In the background, we have on the Server Manager a full reporting, a full data warehouse to have a BI solution, what happens in my environment. When we talk about what we can manage, what we can do, Orchestrator has so-called integration packs. That's like our Lego system. Pre-configured building blocks where we can talk with the applications. So Microsoft has for all its System Center products ready-made integration packs for Active Directory, for a lot of HP components, Service Manager, for the ILO board, for HP OpenView. So we can connect natively to the system and we have the building blocks to talk for it. What does it mean, a building block? For example, standard things like getting an alert from Operations Manager. I use this alert, and from this alert I start working on and do other things. We will see more details on this. So that's what we have natively on the Microsoft side. There is a lot out of the box there, standard tasks on the system, scheduling, file management, text file management, FTP, email, utilities. And there's a huge number of third-party integration packs, like VMware, like BMC, like everything around Linux, Unix, other databases. So we work with certain vendors and providing this. And that's not all. Microsoft has a very strong community, and maybe not everyone is aware, Microsoft has its own open source site where people can contribute, where people can get stuff from individual developed application. Codeblacks.com, you find developed integration packs for other stuff, which has been developed by the field, and they keep developing and doing, so you have your building blocks. What I can do if I don't have it, there's a software development toolkit where you can write your building blocks. So it's very simple to build this. You need to know a scripting language, and then you can do the stuff as well. What has changed from Opalis to System Center Orchestrator? So installation has been updated. It was much better than before. So additionally, we have now integration into Windows Azure. We have a runbook tester. We can test the runbooks, which I will show later, in order to make sure that we don't go to the field without testing. We have encryption. We have better security. That has been improved. Also performance and scalability has been improved, and some other minor stuff. As I said, we can extend it By default, it has 84 standard activities, but we can write additional tools with the integration toolkit or with the software development toolkit and ready-made parts. But that's quickly the introduction and high-level the story. When we look, how does it help for us? So a typical administrator, what is his job? So he has to do new software packages, program requests, servers to deploy. New alert is just coming from operations manager. He has to act on this. He has to send new updates out of it. He has to do a lot of things. So that's the typical job. And these kind of jobs we can automate. The most important thing is by doing automation and integration, first we need to know what kind of tasks, what are the processes, and then write them. Again, back to the other stuff what I mentioned before. You can extend the whole thing with custom scripts or with the integration toolkit. Any standard scripting language you can use. And we have seen many times, and think about your environment. You have multiple servers. On each of the servers, they are sometimes running scheduled tasks. And you use different kind of languages. Depends most probably who is writing the batch file or who is writing the code and what is the problem. You use different tools for different issues. So with the integration of Orchestrator and the possibility to run the scripts, you can create a centralized repository about all your scripts and run it from a central way. You have a central control which scripts has been executed, which scripts didn't execute, and what was the problem. Extension, I mentioned already. Integration packs, I mentioned, SDK. So now let's look at some real world scenarios. Automation is king. Think about it when you deploy a new server. Nowadays, most probably a lot of you have virtualization in place. So virtualization helps us to easily deploy a new operating system. So it doesn't matter if it's VMware, it's Hyper-V. So instead of staying half a day installing the physical server, you can do a virtual machine template, you can deploy it, let's say 20 minutes to half an hour, depends on the size, what is configured. But is this everything you need to do? What else you need to do on your on your server to get it ready for your network? Integration in a batch management, installation of a backup agent, installation of a monitoring agent, antivirus software, different systems which makes really your environment. And in a standard virtualized environment, you just deploy a virtual machine. And then you go again to the different people who are responsible for antivirus, batch management, or if it's only you, you have to do several tasks and you spend another half a day getting the machine ready before it is based on your standards. So with Orchestrator, and that's our tool in the middle, we can do all these things automatically. We get the machine installed, someone requests the machine out of a self-service portal, could be service manager, could be anyone, and we automatically install the machine. Orchestrator is triggering this, and we go to our virtual machine manager, or before in our HP server manager. Virtual machine manager depends if the machine needs to be deployed on VMware or on Hyper-V, will decide where we go, and install the machines, and deploy the machines, start integrating in our backup system, in the Commvault, starts integrating in our batch management. At the end, fully automated. You have installation of the operating system, wait another 20 minutes, you have everything fully automated. You remove human errors and you make sure every machine is the same. That integration is something very simple and can be achieved in a short time frame. So after you install the second server, you already saved the time on doing this. And that's something easy Orchestrator can do. A little bit more complex things is we have incidents, typical problems. So we find an issue, someone calls the help desk, we need to create a trouble ticket, we need to start investigation, we fix it, we have to report it back, verify the solution, and then it takes some time until the whole thing is done. It really doesn't matter how much time it takes, there are different steps, but every step is manual. Every time we need to wait until the next person takes his task, and all these things are happening. And we are all humans, and sometimes we make errors. We forget things, we are not on our place. So certain things can be missed, wrong information entered in the system, all these parts. So this is a typical process in a bigger environment where we have a help desk and what needs to be done. In a more mature way, when we move forward, we can automate things. We can validate the event. We can do pre-check, and I will show this as one of the next steps. Our web service died. I know I can automate, I can check if it's really dead, I can automatically try to fix it before I inform someone and create a trouble ticket. I get all the information, I can populate tickets automatically, I can write and say, I tried this, this doesn't work, so please look at this area. We can go automatically solve incidents sometimes by having certain tools, and that's what I show next. Verify the solution, update the ticket automatically. At the end, we reduce a lot of time, and we're getting predictable. We know what to do. And that's one of the things how we can reduce the cost, we can increase the quality, and we can save our time. I had very interesting discussions today, and I had it 2 days before. I was presenting at IT Pro Bootcamp in Kuwait. Cloud computing is not really taking away anyone's job. So what is currently the thing is 70% or more of our time we spend firefighting, just troubleshooting, getting things up or make sure things are running. And the remaining 30% we are spending maybe on strategic projects on moving forward. Wouldn't it be cool if it turns around? We could do 70%, the fancy stuff, the nice work, strategic work where we can make a difference and have just a little bit firefighting. And that's what's happening with cloud computing. If it's implemented correctly, and if we do, we can save time of work which is ongoing, always the same. We can automate it. So we can use our energy, our intelligence in a way how we can improve the rest of the system. Standard tasks which are every day the same, we can automate. Therefore, we don't need very skilled people and all these things. So we needed to change the things. And this is enabling us really to focus on the strategic parts and do more stuff here in this area. So don't get worried, cloud computing is not taking away anyone's job. Batch management, another topic which is a huge topic, how to do automatic batch management, what components needs to be there. And we need to think about what does it mean if I batch server. And this sample shows that it's not just WSUS or config manager and I go and batch my server and that's it. There is quite a lot of information behind. And if we do professional operations, we have to do this. So we have a service management. Someone requests, I want to batch my servers. I go and do this at a certain maintenance windows. I can't batch my servers during Tuesday morning when everyone wants to work on it. I have my certain service level agreements, my availability. So we go to a website, we have the request, we schedule the whole thing. Once we reach this time frame, we initiate the update and the workflow. So we start moving around virtual machines to make sure we have the hosts ready. But it's not only this, we put the machines in maintenance mode. We are measuring our service line, our service availability level agreements. So if I boot a server without putting it in maintenance mode, I make myself my own KPIs bad. So I'm losing my availability because I didn't put them in maintenance mode. So I automate this. I say, okay, on Thursday night, I want to batch my servers. I want to batch it in a way that my service is always available. I just batch one node after the other. And I want to make sure while I'm batching and the node is offline, I don't destroy my KPIs. It is something planned. And therefore, it should be done. And it doesn't stop with this put it in mode. We batch the machine. That's one simple step. We batch also the installation. We batch the image we are using. So the next time, automatically, the batches are included. I don't need to batch again something which was not online. We batch the master image. One thing, so we're having the image batched. After this, we're gonna check and verify, was it successful? We want to be able to have a rollback, to move back if something is happening. So we need to make sure we verify on all areas. Once it's verified, we continue. We remove the first node out of the maintenance mode. We say everything is fine, and then we start with the second node. This is a fully automated process, but you see there are multiple components coming together. So that's the thing where Orchestrator is powerful, to connect your systems. And batching is every month the same. You do this one time, you save the next month a lot of time. And it's fully compliant, and you have it in your change management database. You know when things have been updated because you see it also in your server manager and in your service management database. Because we do it on the right way via the service manager and we write back the information. So that's possible. That's another example on host batching. So how you do the whole thing. A little bit simplified, but that's as well. So what we see here is the interface, the runbook designer. In the middle, you use the workflow. That's your workflow. Everything which is mentioned red and is down should be the error handling. In case something happens, we want to be able to roll back. We want to know what happened. The key thing is that should be ITIL compliant. So in case something breaks, we get some log files, we know where we are, and we can fix it and continue where we have been. So we need to make sure. So you need to have some intelligence how we do this. I will show a little bit more on this later. But at the end, the cool thing, it's drag and drop the building blocks. That's the integration pack. So we see the integration pack for system has certain commands. I drag the command here, and then I feel inside the variables, what I have, so I can work on it. It's very simple. You don't have to be a full developer to write this stuff. If you can write scripts and write programs, yes, it helps. You can get more complex stuff. But for the standard infrastructure things, that's more than enough and you can do the whole thing. So I'm gonna show one other example, just on the one moment. Imagine we have a website. That's your internet-facing website. Might be e-government, might be a standard website, might be some e-business solution. And the website fails. What are typical tasks you would do now to make this whole thing working? What is the first thing where you would look? Okay, what you would do in IIS? Okay, so we know exactly what are the tasks. So why not using the system and build some intelligent solution that the computer is doing our work? That's why we have computers. We outsource the things to the computer. IT people tend to be lazy people. There's no problem. Lazy and intelligent is a good in combination. We automate a lot of things. But so, what we're gonna do, we capture that the whole thing was crashing. So we see in our operations manager the alert, our website is down, operations manager is connected with service manager. Why I'm writing it to service manager is a simple reason. I want to be ITIL compliant. I want to have all the things tracked, and I want to have it in my reporting later, where I say, okay, it takes this long from a ticket to open until it's closed and all this information. I get automatically in server management. I could trigger some actions as well in operations manager, but we connect both tools to have a more powerful solution. I look in the in the service manager in my incidents, and I see in my incidents the alert that the website is down has been forwarded. I create an incident, but I did not inform or alert someone until now. We know what to do if websites are failing. We have a pre-configured task, web application auto-remediation. We want to fix things. So once we hit this alert, we automatically trigger this orchestrator workflow. And this orchestrator workflow now, and that's not rocket science, it's very simple if we see, has a few commands. We get the incident. That's where we get the incident from the server manager, incident request we saw before. In order to do this, we need the integration back. That gives us the command, get incident. We have the other system ones where we can check the websites. So next step after we get the incident, test website, test our application. If it is working, we move to the other side and everything is fine. We close all the thing, no problem. Was just wrong alert. If it's not working, and this we see by the red color, we go and reset IIS as the gentleman said correctly. After we reset IIS, we test again the website. Is it working? Everything fine. If not, I go and check and reset my application pool. Now, is it working? If yes, it's fixed. We close the alert. If not, then I start alerting my administrator. I do some pre-qualification, I do some automatic remediation, some checks. Now, after I reset it, the application pool, I go back. Surprisingly, the website is working, and all the tickets have been closed automatically in the background. So that's the way how we do auto-remediation, how we can use Orchestrator to do the things for us. So as I said, we want to do things automatically, we want to use it. A bit more complex scenario, and actually I plan to show this, but unfortunately we don't have hardware for the demonstration, is a more complex scenario. A SQL server fails, a complete SQL server. And in real world, to install a new SQL server, let's say it takes 8 hours, 4 hours to 8 hours with batching, with all the thing. So operations monitor that SQL server fails. Orchestrator creates the service manager incident request as before. We have auto remediation. Orchestrator talks to virtual machine manager. We automatically bring back a new SQL server. We have a backup, and we bring back the latest backup from this. In large cloud environments, you tend to reinstall things new and have it replaceable instead of always doing the backup. So we deploy a new virtual machine with SQL, which takes us 10-15 minutes, and then we bring back the database. That's fully automated. This gives us the possibility to have our system up and running in a new in the environment within less than half an hour, fully automated. And this is the thing, you will grow your environment. More and more things happen and you will build this. You will build more integration, more automation. So this is another example of how the things are working. That's the workflow in the background for it. So what we need to do, we get our accident, so then we validate server name, and then we go through the whole thing. Again, that's not rocket science to build this. It looks more complicated as it is. If you start working with Orchestrator, you get really quickly results. As I said, it's drag and drop. Another example on the Office 365, how you can use Orchestrator together with Office 365. Office 365 is a cloud-based solution, software as a service. We just consume. How does it help us? So we have a few challenges. And we see here some of the things what we need to achieve. So we need to integrate. We need to support our end-to-end stuff. We need to automate certain production tasks. We need to be predictable and we need to have certain times. Orchestrate, avoid production downtime. So change is needed. Consistently introduce production changes. That's what we're gonna do. So you have at the end a solution, and that's similar what I showed before. You have a config management where you have your config change, your updates, your builds. You have the process automation workflow. That's all Orchestrator. That's doing the whole work, which is your workflows, your activities, logging for the auditing. It has the portal to show. And then we will update the whole thing, the farms. And that's fully automated. That's how Microsoft does the whole thing. So what are our learnings? Invest time to understand business processes. Automation, we need to have healthy processes. If we automate an unhealthy process, we have an automated unhealthy process. We just hit the wall faster. So it is important that we know what we are doing, that we do inventory of our processes. We need to look, are they good? Is this something really there? Automation framework drives consistency. That's what you want. In order to achieve private cloud, cloud computing, the first thing is what we need to do is standardization. Only when we have standardization we can do automation. If you have too many different standards, it will be difficult or impossible to automate. So you need to be standardized and then consistent. Logging and auditing is mandatory. As I mentioned, you can connect different system center products or management products with each other, but you don't have control if something is happening or if it's not happening. You want to make sure once we trigger, we have full control. We can do a rollback, we can stop things, and we can continue at certain parts. So this is mandatory. So it was just some of the learnings. So again, Orchestrator is really the tool when it comes orchestration, automation, integration, service management, provisioning System Center Virtual Machine Manager, VMware, configuration management, batch management, software deployment. We have ready-made solution accelerators where you can use Orchestrator together with Service Manager and Config Manager, where you can go to a website and ask for software deployments. You have a workflow behind. If it's software which costs money, which you need to classify, it will go to your manager. If not, it will be deployed. All these components together to having this automation, having these things, comes at the end via the orchestration as a key thing. That's the brain work that's doing all the stuff. Monitoring, triggering things based on alerts, that's monitoring. And doing automated backup and recovery. So this can help you to build dynamic data centers. We had today the question in the morning, can we do data centers across multiple sites? Yes, System Center 2012 is your key enabler. You don't want to have a, sorry to say, stupid DR site, which is active, passive. You waste a full data center and only if there's really a problem you activate it. You do a full SAN replication. You have a data center which is not used beside you have any problem. This is old thinking. What we want to achieve is active data center. I want to use both of my data centers at the same time. I want to spread workloads across. These things are helping you to build this, to monitor and based on events, to provision new workloads, to grow, based on certain events to move workloads. So in case we can't achieve natively by the application active, you want to achieve at the end 50% of the workloads on data center A and the other 50% on B, and have intelligent movement that you say you can modular shift workloads. And that's the thing what you need to, therefore, and you need to do, is Orchestrator can help you to build these workflows. Any questions? Yes, please. So active data center, as I said, the baseline to achieve this is what we call fabric management. That's the whole system center. That's doing the logic, that's doing work distribution monitoring. And the other part is the infrastructure side, the fabric. That's the Windows 2012 platform. Either you do geo-clustering. If geo-clustering is not an option, you have clusters in the data center A and data center B. You have the fabric management, which is doing all the automation. And then you need to look in each of the workloads, how the workloads are built, what kind of architecture. Does the workload provide site resiliency natively? If it provides natively site resilience like Exchange, you can easily spread across data centers. Then it's very simple to extend. You just deploy on both sides client access server, hub server, and mailbox servers. If it doesn't provide natively, that's where we say you need the fast failover, that it can run 50% on this side, 50% on the other side. One option would be Hyper-V replica. Other option would be service templates from Microsoft and move the whole thing to the other side. So there are multiple ways how we can achieve this, but at the end you need to build the platform, the enabler, that's your system center. And then for the applications, you need to look in each of the workloads separately. Depends really what are your application, how can we make them site resilient or not. I'm not sure example. We are doing this with quite a few customers, but that's customer data, so unfortunately I can't really share with you. But if you look online, there are certain things. And I did 2 years back at DECHED a presentation for geo-clustering and how you can achieve certain things. I can share at least this presentation if you like. Any more questions? Yes? So with physical machines, it's always more complicated because you can't move a physical machine. So that makes the whole thing complicated. So really active data center and dynamic data center will be only possible with virtualized workloads because you can move them, you can shift them. So with physical hardware, you will always have a limitation. You can achieve a hot standby site, or you can achieve, if the software supports active, but I cannot dynamically grow and I cannot dynamically shrink. It's physical hardware, so while I can shrink and grow and move around as I want with virtualized workloads, that's the key advantage. It's still management, but you have limitations on physical hardware. Just one example, if you need certainly to grow your footprint because you have a high demand on capacity, you can order new servers. That's possible. You will get, in this part of the world, 12 to 18 weeks. You can provision, but you can't send them back if you don't need them. So that's the problem with physical hardware. So while you have on a virtual hardware, yes, you need to have your base capacity, but you can easily provision and you can decommission if you don't need. So that's the full advantage there. There will be still always traditional hardware. There will be reasons for it. You need a hardware dongle, you need certain things. But the majority is moving completely to virtualized. And then you have the advantages. We go even one level further where we say hybrid cloud scenarios, bursting to the cloud. That's very interesting. A lot of the oil and gas companies worldwide are looking into this. What was before local high-performance computing, they're looking now, how can I use the cloud to execute huge calculations, just burst certain cycles out to the cloud, and then after I don't need it, I keep the whole environment just internally. And that's the whole thing, this dynamic, that's one of the key things driving this cloud. And with physical hardware, you can't have this. Okay. So thank you very much. I think you want to say something? I'm done. If there's no more question, I will be around if you have any more question. I got a list of answers which I have to send or presentations. I will do this tonight. Otherwise, I say thank you very much for your time. I hope you enjoyed.